6.2, gas pressure. Now, if you look at this picture here, you're noticing that here we have this beautiful lake and we have a beautiful mountain and we have these arrows, and you're wondering, why are these arrows pointing down? But notice, we have on our arrows P equals 1 ATM, and up here at the top of this mountain here, P equals 0.70 ATM. Well, let's learn a little bit about what that means. First of all, gas pressure is a force acting on a specific area, so it's the force over the area when they're talking about pressure, which makes sense. But it has these different units. The ATM, as in atmospheres, the mmHg, as in millimeters mercury, the torr, the pounds per square inch, or the kilopascals. In this class, we're going to use our ATM, our atmospheres, our millimeters mercury, our torr, and very rarely, but maybe, and we think about it in pounds per square inch. However, here's our conversions right here that you need to write down, that 1 atmosphere is 760 millimeters mercury, or 1 atmosphere is 760 torr, which means 1 millimeter is 1 torr. They're the same. And so we can use them as conversions, which we're going to use at the end of this section. An atmosphere is 14.7 pounds per square inch. So when you put air in your tires and you go, oh, well, I need my tires to be 28 pounds, you'd usually might just say 28 pounds, but usually it's 28 psi, as in 28 pounds per square inch. If we wanted, I could have you convert that to atmospheres, so of course we're going to figure that out. So here we go. First of all, we have different devices that measure the pressure, and you may think, oh, well, I know what device measures the pressure. When I go and check the air in my tires, it's that silver thing that the thing comes out. Well, yeah. Well, here we go. A barometer measures the pressure exerted by the gases in the atmosphere. It indicates atmospheric pressure as the height in millimeters of mercury. So let's look at this. This is a good diagram here. We have our liquid. We have a bulb that's filled with mercury, and air is pushing in all directions. And it's pushing down on the mercury, just like it would push down on water if we had water. And the air pressure pushes the mercury up. Now, if you're at sea level, at normal atmospheric pressure, the height, if you were to go and get a meter stick, the height that it would measure that would be 760 millimeters mercury. Well, you might think, why in the world are they using mercury? Well, because it's a liquid, and they need a liquid to be able to push it up to fill the tube or to go up, however. You go, well, why don't they use water? Well, because water's a lot less dense. Mercury is such a dense liquid. And if they used water, then you'd have to be going up out of a 2-story building and taking the measurement there, because it would be such a high tube up, 2 stories high. Whereas this is just a little bit, it's not all that high. 760 millimeters mercury. So atmospheric pressure is the pressure exerted by the column of air from the top of the atmosphere to the surface of the earth. As we go higher and higher and higher on a mountain, you will notice that the atmosphere is going to decrease. So at the top of this mountain here, the atmosphere is 0.70. It's less than 1. Whereas here on the, it should be, like, let's assume that this is right at sea level, even though I haven't been to too many seas that have the mountain right by it, but sea level, it is 1 atmospheric pressure. So what's important is to know that as you go higher in altitude, there's less air pressure. And you already know that, because I know you've probably gone to Flagstaff, and if you've ever tried to jog at Flagstaff, all of a sudden you're going, and you're wondering, why the heck can't I breathe? There's no oxygen. Well, actually, the better definition is there's not as much air. So there's not as much oxygen, there's not as much nitrogen, there's not as much any of the components of air up there. So let's look and see. So here's sea level. The altitude is nothing, okay? So our atmospheric pressure, the normal atmospheric pressure, is 760 millimeters mercury. When we go up in altitude, notice the pressure becomes less. Now Denver is called the Mile High City, so it's probably 5,280 feet. Notice Denver's altitude in kilometers, 1.6, but look and see what its atmospheric pressure is. 630 is its normal atmospheric pressure, which is less than 760. So Denver, maybe you haven't gone to Denver. Well, Prescott, Arizona is about the same altitude. So the atmospheric pressure in Prescott is going to be 630 on a normal day rather than 760. And if you go up higher these mountains, you'll notice the atmospheric decreases. If you go up to Flagstaff around 7,000 feet is going to definitely be less than 630 millimeters mercury. You may go, well, what does that have to do with anything? Well, it has to do a lot with a lot of things besides you just trying to breathe when you're jogging down the street. But first of all, let's think about this. In your life, you have some things that already have their air pressure their pressure that's measured. So I want you to think about what unit. So what unit is the gas pressure in your car tires measured in? You may go, well, it's 32. 32 what? Well, here it's probably PSI. If you were in Canada, it would be the kilopascals. Okay, number 2. What unit is the gas pressure when the nurse takes your blood pressure? And you may go, oh, well, my blood pressure is 117 over 70. Yeah, 117 what over 70 what? You will be surprised. So ask your nurse the next time. When you're listening to the evening news, the weathercaster is going to be talking, or the meteorologist is, I guess, the updated word, gives the barometric pressure, and they go, oh, well, it's 29 and falling, or 29 and rising. 29 what? What are the units of measurement they use for that? Can you think of anything else? Hopefully you can. So here we go. Let's do a little bit of math. What is 475 millimeters mercury expressed in atmospheres? And the pressure in a tire is 2 atmospheres. What is this pressure in millimeters mercury? Well, this is where we go back to the slide that has our conversions, and this is what we're going to use our conversions with. Here we go. And you need to do that. So press pause, see if you can do that. All right. What is 475 millimeters mercury expressed in atmospheres? So 475 millimeters mercury. We're going to use our 1 atmosphere is 760 millimeters mercury, but do we put the 760 millimeters mercury on top, or the 1 atmosphere on the bottom, or the 1 atmosphere on top and 760 millimeters mercury on the bottom? Well, we must cancel out our labels in millimeters mercury, so that means our conversion has to be set up this way. 1 atmosphere is 760 millimeters mercury. So we multiply through by 475 times 1 divided by 760, and we get 0.625 atmospheres. The pressure in a tire is 2 atmospheres. What is this pressure in millimeters mercury? Well, now we're converting from atmospheres to millimeters mercury. We have our basic unit conversion, so which way do we flip it? Well, we start with 2 atmospheres, so 2.00 atmospheres. That means that our 1 atmosphere label must be on the bottom. So 760 millimeters mercury over 1 atmosphere. So our labels of atmosphere cancel out. 2 times 760 millimeters mercury is going to give us our 1,520 millimeters mercury.